Hi, good day all of you. Welcome to our session. Welcome to our channel, Intelligible Tutorials. In this today's session, now we are going to see the Bayesian approaches. In my past video, I have told regarding conditional probabilities, and now we are going to see the Bayesian approaches. So, normally these Bayesian approaches can be used in statistical reasoning of the artificial intelligence. So, to handle the uncertainty and predictable problems normally. So, derive the probability. Normally, it can be derived as this Bayesian probability can be derived as it can be derived of an event given another event. So often very good method for using in the diagnosis of any kind of the diseases. See here we see if X are effects and Y are causes. X are observed effects and Y are hidden causes. We may have a model for how causes leads to effects and probability of X on Y. We may also have some prior beliefs. The prior beliefs are based on experiences about the frequency of occurrence of effects of probability of Y. This can be derived as. And it allows us to reason abductively from the effects to causes, that is probability on Y on X. So what we have actually, we have model how causes leads to effects, that is probability of X on Y, and we allows us to reason abductively from effects to causes, that is probability of Y on X. So this is probability of X on Y and this is probability of Y on X, and it has gained very good importance due to its efficiency and highly accuracy it is showing. So but it requires some large computational power and often considered as the very good and efficient method of this statistical reasoning. And how this Bayesian rule can be represented for a single event. So for a single hypothesis H and single event E, it can be represented as the probability of H on E is equal to probability of E on H into probability of H by probability of E, or probability of H on E is equal to probability of E on H and to probability of H divided by probability of E on H into probability of H plus probability of E on negation H into probability of negation H. Like that, the single hypothesis H and single event E can be represented like this. So the base example that can be represented as like this. So stiff neck is a symptom of 50% of the meningitis cases. Okay, so meningitis occurs in 1 by 50,000 people, 1 by 50,000 patients. So stiff neck occurs in 1 by 20 patients. Then probability of stiff neck on meningitis, probability of S on M is equal to 0.5. That is, and probability of meningitis is 1 by 50,000, and probability of stiff neck is 1 by 20 patients. Okay, which we have, and we are going to calculate the probability of the meningitis on stiff neck. This can be calculated by using probability of stiffness on meningitis in, into probability of M by probability of S. Probability of M means probability of meningitis divided by probability of stiffness. And now we are having that is probability of S on M is given as 0.5 into probability of meningitis is 1 by 50,000 divided by 1 by 20, which giving the value of point not 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 2. So by using this calculation, we can expect that 1 of 5,000 patients with a stiff neck to have meningitis. Okay, so like that we can calculate the Bayesian example by using this particular formula to calculate the probability of meningitis on stiff neck. And now what are the advantages and problems of the Bayesian reasoning? Normally, the advantages of the Bayesian reasoning is very good. It's highly efficient, highly accurate, and sound theoretical foundation, and it can be used in good decision making also. And at the negative end, it is also having some kind of the problems also, whereas it requires large amounts of the probability of the data and sufficient sample sizes, and subjective evidence sometimes may not be reliable, and independence of evidence effect assumption often not valid, and relationship between hypothesis and evidence is reduced to a number, explanation for the user is difficult, high computational overhead. So here in the list of these number of the problems, we have the main things to remember is it requires high large amounts of the probability, and it requires high computational powers, and explanation overhead is also there whenever you are going to explain it to any kind of the users, and independence of evidence normally are not valid, and the hypothesis and evidence is reduced to a number like that. So many number of the negative ends are also there apart from the advantages by using this Bayesian learning. And what are the other issues with the probabilities are also there. So what are they? Just we narrate them. So often don't have the data. So probability is something sometimes we may not having the data, just don't have the enough observations, and data can't readily be reduced to numbers or frequencies, suffers from space, time and computational complexities. Human estimates of probabilities are notoriously inaccurate, in particular often add up to greater than 1. Okay, it always does not match the human reasoning well. So not enough data and not matched to the human reasoning, and several other approaches for uncertainty addresses some of these problems like that. So many number of the issues are there with these particular probabilities also. So in the coming classes we are going to discuss about Dempster-Shafer theory. Okay, so this is about the statistical reasoning, this is about the Bayesian rule for single event and all. So if at all anybody didn't subscribe my channel, please subscribe my channel, Intelligible Tutorials. Thank you one and all.